So, we have a new speaker, Marcus Bengtsson. Please take the stage. Welcome aboard.
Thank you. So, okay, you are there. I'm here. That's the lunch. So obviously, I have 15 minutes in front of me. I'm going to talk about cloud, not because in the weekend we have been being that patching guy. And probably all of the speakers before me have been talking about WannaCry. But I have another touch on it because I'm going to use a real-world example because one of our customers were infected. And I wanted to share some knowledge about what the effects were and what we had to do to support them. So just some background. The 14th of March, Microsoft released a patch. Obviously, there was some type of loophole because the information that Microsoft got there were released a month later by the shadow brokers that got the information from the equation group that people believes, at least Microsoft believes, is tied to NSA. So then 1 month later, we get WannaCry. And the takeout from this slide is that now we have the traditional patching hole that we're seeing is that it's 90 to 180 days. Now we're down to 60 days. So the question is, even if a vulnerability gets released, it takes quite some time to get the patch out, and then it takes even longer time for you guys to get it deployed. And 60 days is quite a short time. So I know it's perhaps I'm stretching a little bit far, but were there anyone in this room that weren't patched when WannaCry got out? Did everybody have the patch deployed? Oh yes, yeah. And nobody were running XP or 2003 servers. No. And if you did, all of those were isolated and protected, of course. Yeah. So to be fair, I think that everybody in here agrees on that this is a challenge. So just, I mean, you have seen all the numbers. Is it 150 countries or is it 90 countries or whatever? It doesn't really even matter because what the takeout here is the last point. It's self-propagating. So it's kind of the worm. The worm is back. And I'm going to give you a slide about how effective the worm is. But we have been doing testing, and you can also find movies on YouTube. But we tested this over the weekend, and it takes 2 to 3 seconds from an infected machine to reach the next machine. So it's also got so effective that actually Microsoft did something very, very unusual. They released a patch for a system that is not supported anymore. So, I mean, if you're talking to your, the C-level saying that, well, actually, we believe that we need a little bit more money. I'm going back. I mean, this is a really clear statement saying that even Microsoft, it's not really normal for Microsoft to do this, all right? Then you need to buy their expensive premium support package if you're going to get support for those old systems. So this is the customer. So I need to walk you through what you're seeing here because it's a little bit technical. So the customer is running a traditional antivirus, and the numbers that you see on the left is what McAfee is classifying as this is a file we haven't seen before. It looks a little bit suspicious, so we want to send it to the cloud to get a second verdict. That means that this file, all of this file have executed. Are you with me? So what you're seeing on the left is, not even I can see it, but of course it's the 12th of May on the left, and then you see the weekend. And I mean, we had millions of infections, but the customer only had 40,000 endpoints. And maybe 20,000 of them were online because it's a global company. Some of the regions had gone home. Not all of them were connected to the network that got infected and so forth. So let's say around 10 to 15,000 endpoints were vulnerable because they hadn't deployed a patch, and they had old legacy systems. So how can we then reach millions of infections? Well, actually, this worm doesn't look to see if the client is infected. So it's just going over and over and over again. And since it's propagating within seconds to the next machine, I mean, it's like a nuclear explosion. So what you're seeing is that more or less within hours, almost all machines and servers that were vulnerable were infected. So this is the difference between WannaCry and the other ransomware that has been out there, because this actually is self-propagating. And imagine if something that is really bad, because I'm coming to that. WannaCry was really a crappy ransomware. But if you are putting a bigger bomb to this type of vulnerability and toolkit, then I would say that we would have another situation. So what did we do then? So first of all, we had to isolate all the infected machines. We had to block SMB traffic in the firewalls. We had to reinstall and patch. We had to segment. Luckily, there were a guy in France, I think, that found a killer switch. And a killer switch is actually a DNS record that weren't online, but it was hard-coded in the code, meaning that this guy bought that domain and put it online. So all the agents, malwares, that managed to reach this DNS query didn't work. They didn't encrypt. The thing was that we realized that this is not proxy aware. And since this customer were running a HTTP proxy, we had to configure the internal DNS servers as well. So that took some time before the industry figured that one out. So I don't know what the motive is. I don't think that anyone knows that, to be fair, because when you look at from a money perspective, yesterday evening they got around 70,000 US dollars in bitcoins. And if you compare that to what Angler managed to get, it's not money. Or if it was money, they failed. So they got publicity, maybe it could be that, but I don't know. Is there anyone in here that has an idea what the motive could be? Okay, so the code, was it built by masterminds? No, it wasn't. It was really bad code, to be honest. So first of all, the Bitcoin addresses is hard-coded, meaning that if you pay the ransom, it's a manual process for the mastermind in the background to actually figure out which key is yours. And when you look at it, it's like we have a handful, 2 handfuls of customers that actually tried to pay for a couple of machines just to figure out if it worked, and none of them have received their encryption key. I saw that Mikko Hyppinen at F-Secure, he went out and said that F-Secure had some customers that had received the key, but not all of them. So basically the trust model is broken, because historically if you have paid, you have gotten the key. So then we have said don't pay, because then you're giving money to an industry that you don't want to grow, but still, I mean, paying is obviously the only chance you have if you don't have a backup. The check payment button, that is kind of the support thing, doesn't work. And there is a kill switch. Why implement a kill switch? And if we implement the kill switch, why do it so rudimentary so we can read it in clear text? And it's also very easy for us to reverse the code. I mean, a couple of more days with a great engineer, it would have been so much harder to reverse engineer the code. Recommendations: don't pay. The trust model is broken. You can't wait 90 days to patch, okay? I think that's a key takeaway, okay? We need to think otherwise. We need to think in new ways, new dimensions. You know, I don't know what you're gonna do, but we need to think different. Firewall segmentation, please. If you have systems that is more vulnerable than the others, and please put them on another segment to make sure that the endpoints can't reach them. Backup, of course, it's obvious. Training, yeah, everybody says, hey, it's always the end users that is clicking on all the stupid links. Well, my first assignment in this industry was actually to teach people within en commune to learn to double click, because the ladies in the reception, they haven't figured out how to double click. So they were only running DOS programs before, and then you can put the enter button. And now they got a mice, and they need to learn how to double click. So then I told them, you need to double click. And now they receive an email and say, of course, I'm going to double click. So I mean, it's a behavior that is built in. We're not going to change that. So of course we can train our end users, yeah, but it's not going to be enough. And lastly, I have to say, I mean, if you have bought our endpoint protection service, you would have been protected since November in 2015 without signatures. Okay, that's the only commercial part. So then I got a couple of customers calling me and saying, you know what, is it over now? And I would say, no, it is not. We have already seen several mutated samples with new killer switches, no killer switch. People actually kind of doing the same thing that we have been doing, reverse engineering the code and rebuilding it so it works better. So for all those companies that haven't patched and believe that it's over and that you trust your signature antivirus, sorry guys, you don't have the time to be here. One motive that I read about is that shadow brokers that got all these nice tools for hacking the NSA, they're trying to sell their tools, but they're struggling. They're not getting the money that they were expecting. So one of the motives could have been marketing. So because yesterday, I think it was, shadow broker went out and said, now you can buy a subscription model. So every month we're going to release new tools and new vulnerabilities. And I mean, if those tools and vulnerabilities is even close to what these were, then it's going to be a problematic future for us. So if you're going to have some key takeaways before we go to lunch, I think that, first of all, we have seen the first really, really nasty self-propagating malware. This is actually Pingis balls floor that Pepsi used for commercial. So they have like rigged millions of these ones and send one in, and then everything explodes. And that's actually what's happening when a customer gets hit by this. The trust model is really broken. So I mean, I have customers that has Bitcoins in their budget. Hey, if we get ransomware and we don't have a backup, at least we have some Bitcoins in the budget so we can pay. I mean, it's not going to work anymore. Buckle up, because it's not over. I think that what we see now is a worm that's really taking the industry really hard. I think we're going to see some really interesting things in the future. That was my 15 minutes.